All right, hello class. So welcome to lesson 3-4. So we're going to be talking about exclusively the operation of division on polynomials. So how do we divide polynomials? Our learning goal is to be able to perform long division on polynomials. The standard is to be able to rewrite simple rational expressions in different forms. For example, writing a of x divided by b of x in the form of q of x plus r of x over b of x. So we'll talk about that. That's called the quotient form for long division. All right, so we're going to be talking about the factor theorem and the remainder theorem in this lesson. So this is the vocab for 3-4. All right, so let's talk about the operation of division, just division in general. All right, so you got to remember a few key terms here. So if we're taking 15, if we're writing 1569 divided by 13, well, that is the same thing as the fraction 1569 over 13. These two mean the same thing. So when we're dividing these two numbers together, we can write it in both of those ways. Now, when you do a division table, this is like long division, right? The standard form of division. You put, so this right here, the dividend is what goes inside the table. So that's the 1569 here. In this example, the divisor is what you're dividing by. So the dividend is what you're dividing into. The divisor is what you're dividing by. So that's going to be 13. The quotient is the answer to the division problem, right? So once we get that, I'll write that in the quotient, right beside the quotient. Right, so let's just kind of recall how to divide two things together, right? So in the standard way, you say, well, how many times does 13 go into 15, right? So in that case, you would say, well, 13 goes into 15, one time. So you write the 1 there. And then you would say, okay, well, what's 1 times 13? Well, 1 times 13 is 13. And then you subtract the two numbers, right? So you're subtracting the two numbers, and then you get 2. Then you bring down the next term, or the next number, 26. And then you say, how many times does 13 go into 26? And then you rinse and repeat here, which is going to be 2. And then 13 times 2 is 26, so you get 0. Bring down the 9. So in this case, you have a remainder, right? So at this point, we could write this as 12, remainder 9. However, that's what you do in elementary school or middle school. We don't when we do this in algebra, we don't write it with the remainder and then 9. We write it in two ways. Okay. First way is a product form. So you can write it as dividend equals quotient times divisor plus remainder. So we'll actually include another thing here for remainder, since we didn't include that here. So in this problem, the remainder is 9, and the quotient is 13. So we got those four things involved in a division problem. So to write this answer in a product form, right? So we'll call this, 1 and then 2. So to write this problem that we just did in the product form, well, we say, okay, well, the dividend is 1569, and that is equal to the quotient that we just got. I wrote the quotient as 13. I apologize. This should say 12, not 13. The quotient is the answer, is this guy here. That's the quotient. So the 1569 is 12 times, and I'll just use the dot for times instead of the x. So 12 times, and then our divisor, which is 13, plus the remainder of 9. Okay, so that is how you write it in the product form. Well, 12 times 13 is going to be 1560, and then 1560 plus 9 is 1569. All right, so the second way, the quotient form, which is, by the way, the method that we prefer most of the time, is the quotient form. So you take, well, you say, all right, well, what's 1569 divided by 13? Well, that's equal to 12 plus remainder of 9 over the divisor of 13. So that's another way of writing the quotient form. So like I said, this is the way that we usually prefer to write it in. But you will see both forms. I will ask you to write both forms. But quotient form is actually the standard. So if you go back to the standard, you may recall that it wants you to write it in the form, well, q of x equal to, r of x over b of x, and then some polynomial p of x, something like that. So that's the standard to be able to write a quotient in that form, which is why we prefer the second way. All right, so we did this with numbers, right? You may have remembered division, you may have not. So either way, this would have been some kind of refresher. Let's apply this to polynomials. So we're going to do the same process, and I went ahead and this is from the previous example. I went ahead and just kind of did a quick picture of what we did last time, with the process. And we're going to compare those two. So again, we're going to use long division to divide p by d of x. So in this case we have, this is p of x I'm going to divide that by d of x. So in order to do that, you're going to have, remember that this is the divisor. X plus 3 is the divisor. That goes on the outside. And then you're going to put your dividend inside the table. All right, so how do we apply the process here of long division? We're going to do the same thing that we did with numbers, all right? Instead, you just have letters here. So you're going to say, well, how many times does x plus 3, or how many times, let's look at this guy. How many times does x go into x cubed? Well, how many x's are missing, right? We're missing 2 x's. So x goes into x cubed x squared times. All right, we got that taken care of. Next, you would multiply the two things together. So what is x squared times x plus 3? Well, x squared times x is x cubed. X squared times 3 is 3x squared. It's positive. And then what do we do once we multiply? Well, we do what we did here, right? We subtract. So we did the 13 times 1 to get 13, right? And then now we're subtracting, right? So we're going to do that here. So now we subtract. And I'll put this in parentheses too, so you can kind of see that. So now x cubed minus x cubed is 0. 5x squared minus 3x squared is 2x squared. All right, then what do we do next? We bring down the next term. You can see that we did there, so we're going to do that here. Plus 6x. All right, so now x goes, how many times does x go into 2x squared? Well, there's one x missing, so we know that is going to be, x is positive x, right? Because x times x is x squared. And I'm missing a 2 as well, right? Because 2 times 1, there's a 1 here, is 2. So x goes into 2x squared 2x times, positive. All right, so now let's multiply that again, right? Distribute. So 2x times 1x is 2x squared. And then we're subtracting. And then 2x times 3 is 6x. Subtract those, again, just like we did here. And you get these cancel out. These become 0 basically, right? So you got 0 here because they cancel. Then you're going to bring down the next guy. So bring down the 9. And if you look at this, well, this is a remainder, right? So this is our remainder. So now we have our quotient, right? This is our quotient. So we're going to write it in the answer in both forms. We're going to write it in the product form and the quotient form. So if we write it in the product form, I'll call that 1. That would be, here actually we'll write it out. So this is product form, and then this is going to be quotient form. So the product form is, well, we have our dividend equals our quotient times divisor plus our remainder. So that, let's isolate this here. This is our product form. Our quotient form is our division problem equals the quotient plus the remainder over the divisor. Kind of zoom in on that. So this right here, was the quotient. And that was our remainder. And that was our divisor. All right, so we're going to repeat this process for part B. So we're going to divide these two polynomials together. So again, the top guy is my dividend. The bottom guy is my divisor. So we're going to set this up in a traditional format. Okay, so that goes on the outside of the table, right? Now for this, now notice that in the previous problem, right, we had all the powers in order. We had 3, 2, and 1. So if you're missing any powers, you want to make sure that when you do this division problem that you include all the powers in between. So if you're missing like a 2 power or a 1, you want to make sure that you include those. So in this case, we have a 3 power, but we have no x squared power. We have no x power. So what we're going to do is we're going to put placeholders for those. Okay, so we have 8x cubed, and this is the part that is key here. Since we're missing the x squared, we're going to write that as 0x squared. And that just serves as a placeholder that say, hey, we don't have any x squared terms. We're going to write this as 0. And then same thing for the x term. We don't have any x terms, so we're going to write this as 0. And you'll see why this is going to be useful, because we're going to have to subtract those. And then we have plus 27. So basically, if you don't have those powers, make sure you include them. All right, so now 2 goes into 8, well, 4 times. 2 times 4 is 8. X, how many times does x go into x cubed? Well, you're missing 2 x's there, so 2 and 1 make 3. Now go ahead and distribute, multiply. So 4x squared times 2x is 8x cubed. 4x squared times 3 is, times positive 3 is positive 12x squared. Now you see why I included that x squared term there. I included that x squared term in the beginning, that 0x squared, so that I have a placeholder so that I could subtract x squared terms together. Okay? So now I'm going to subtract these two together. So now this is going to be 0. I'm going to erase these arrows now. All right, so 0 minus 12 is negative 12, and then x squared. All right, now I'm going to bring down the 0x placeholder, and I'm going to continue rinse and repeat. So 2x, how many times does 2x go into negative 12x squared? Well, 2 goes into negative 12, negative 6 times. And then if I included x, well, x times x is x squared. So that works out. So now multiply. or distribute. So 2x times negative 6x is negative 12x squared. Negative 6x times positive 3 is negative 18x. Alright, so now we're going to subtract. So negative 12x squared minus negative 12x squared cancels, goes away, is 0. Be careful with this part. 0 minus negative 18. That's the same thing as positive 18, right? So let me write this off to the side just in case. So 0 minus, that's this first minus here, and then minus negative 18x, right? That's because of this negative here. So two negatives make a positive. So this becomes 0 plus 18x. So basically this becomes a plus. And then 0 plus 18x is 18x. So just be careful with the signs. Alright, so now bring down the 27, the positive 27, and then rinse and repeat. So 2x goes into 18x 9 times. 9 times 2 is 18. Plus 9. So then you distribute. So 9 times 2x is 18x. 9 times 3 is 27. So then now you subtract. So everything cancels out. So it looks like you have a remainder of 0. So the remainder is 0. That means it goes into it perfectly. All right. So now let's write our answer in the two forms. Let's write it over here. So we have the product form is going to be given by, so it's going to be dividend, and we don't have to write the 0 anymore, the 0x squared. We could just write it as 8x cubed plus 27. Dividend equals our quotient times our divisor plus a remainder of 0. All right, well, you can ignore that remainder of 0 because it doesn't really do anything to the equation. So you could just leave it as, you could just ignore it, okay? And then just write it like that. And that's our product form. Now we have our quotient form. So we have 8x cubed plus 27 divided by 2x plus 3. That's equal to our quotient plus our remainder, which is 0, divided by our divisor. But like we said earlier, this goes to 0, right? That's just 0. So we can ignore that and just write the answer as 4x squared minus 6x plus 9. Okay? So we can just kind of ignore that. And our final answer is going to be that. So these are our two guys. All right, go ahead and give it a try and pause the video and we'll talk about it in a little bit. All right, so let's look at the long division here, part A. So we're going to kind of breeze through this real quick. So we got x cubed minus 6x squared plus 11x minus 6, and that is divided by x squared minus 4x plus 3. So we have the x squared minus 4x plus 3 on the outside, and this is on the inside. And we're not missing any powers of x, right? We got 3, we got 2, we got 1, and we got no power. So we got all the powers here. All right, so now x squared goes into x cubed x times, because x times x to the 1 times x to the 2 is x to the 3. So now distribute. So x times x squared is x cubed. X times negative 4x is negative 4x squared. And then x times 3 is 3x, positive. And then now we subtract. So let me get rid of those arrows here. All right, and then this goes away. Now be careful with this part, negative 6x squared minus negative 4. So this becomes a plus. So negative 6x squared plus 4x squared is negative 2x squared. And then 11x minus 3x is 8x. Bring down the minus 6. And then you rinse and repeat. So x squared goes into negative 2x squared, negative 2 times. Then distribute, so negative 2 times x squared is negative 2x squared. Negative 2 times negative 4x, positive 8x. Negative 2 times 3 is negative 6. Subtract those two together. This becomes two negatives here, make a positive. So that goes away, that's a 0. 8x minus 8x is 0. And then two negatives make a positive, so this would be 0 as well. So the remainder is 0. So then if we write it in our product form, we have for part A here. So we have our x cubed minus 6x squared plus 11x minus 6 is equal to, it's equal to our quotient times divisor plus remainder. And the remainder is 0, so that is our product form. Now let's do our quotient form. So we can ignore the remainder because it's 0 there. And then, so now for our quotient form, we have x cubed minus 6x squared plus 11x minus 6 over x squared minus 4x plus 3 is equal to x minus 2 plus the remainder of 0 over, that. But again, this remainder is 0, so you can ignore that, right? So that goes away. And we're left with this as our quotient form. All right, so notice that this right here is in the factored form, right? So this is the product or factored form. So the product form is kind of like the factored form, as long as the remainder is 0. We'll talk about this in a little bit. But let's go back to part B. So we have 16x to the 4th minus 85 divided by 4x squared plus 9. All right, let's continue with part B. Just wanted to free myself of some room. So let's do 16x to the 4th. We're going to go straight to the division table, by the way. So now notice that we're missing some powers here. We have 4, we're missing 3, 2, and 1, right? So we're going to write those powers out on the inside. So we have this is going to go on the inside, so 16x to the 4th. Now we're missing an x cubed power, so I'm going to do 0x to the 3rd. I'm missing an x squared, so 0x squared. And I'm missing an x term, so I'm 0x. And then minus 85. So we're going to divide that by 4x squared plus 9. Also going to give myself some room here. All right, so now we have enough room. Let's go ahead and get started. So now with this guy, we have, how many times does 4x squared go into 16x to the 4th? Well, 4 goes into 16 4 times, and x squared goes into x to the 4th. Well, we're missing two x's there, so I'm going to write x squared. All right, so now we multiply. 4x squared times 4x squared is 16x to the 4th. 4x squared times 9 is 36x squared. So we have a 36x squared here. So basically we have no x cubed terms, right? So we can just kind of write that there as a placeholder. So then we subtract. So that goes away. There are no x cubed terms, so just ignore that. 0 minus 36x squared is negative 36x squared. All right, so now we have to bring down the 0x just in case we need that. And okay, so now we'll do, how many times does 4x squared go into negative 36x squared? Well, 4 goes into negative 36, negative 9 times. 9 times 4. And then, so we have negative 36x squared if we multiply those two. And then what's negative 9 times 9? Well, that's negative 81. So that's not going to go here, right? That means we have no x terms, and we have a negative 81. So let's go ahead and bring down this negative 85 so that we can subtract those. All right, so now we're going to subtract. So now this becomes a positive because of these two negatives. So basically these cancel out, positive and a negative 36. Ignore that, 0x minus 0x is 0. And then negative 85 minus negative 81, this turns into a plus. So negative 85 plus 81 is negative 4. So that's our remainder. Our remainder is negative 4. So if we want to write our final answer, right, we need to write it in the product form and quotient form just to practice. So the product form, 16x to the fourth minus 85 is equal to, that's our dividend, equals our quotient times our divisor plus our remainder. And our remainder is negative 4, so I'm going to write it as minus 4. So that's the product form. Now let's do the quotient form. So we have our division problem. So that divided by 4x squared plus 9 is equal to, well, 4x squared plus 9, and then some change, right? So we put our remainder. So our remainder is minus 4 over our divisor. And that's our quotient form. All right, so now let's go ahead and quickly talk about not the previous problem that we did with the try it, but the one before that, right? So our very first example, when we were dividing x cubed plus 5x squared plus 6x plus 9 divided by x plus 3. So I went ahead and jotted down the results. So this right here was the quotient form. This right here is the product form on the right side. So I want you to note that when we have a remainder, you know, that remainder is on the outside, right, of the product form. Now, when the remainder is 0, I want you to note this special case, right? So for part B, the remainder was equal to 0. So this one had no remainder. So when it has no remainder, notice that the remainder here is 0, right? And we could ignore it. This is factoring, right? So if I told you what, you know, factor 8x cubed plus 27. If you were to factor 8x cubed plus 27, you would write it in this double parentheses format. So you can write a polynomial as the factored form by dividing if you know what one of the factors are. So if you know that this polynomial is divisible by another polynomial, then you can write it in factored form. Let me explain that further. So let's look at this example. So we have a polynomial, I'll call it p of x, is equal to x squared plus 2x minus 5. And what I want to do, I want to illustrate, is I want to first factor this. So let's review factoring. So remember when we factor this, you set up a table like this, and we have, well, we want to find numbers that multiply to get to negative 15, but add up to get to 2, right? So the negative 15 goes on top, two numbers that multiply to that add up to 2, positive 2. So we'll put a plus sign there. So in that case, that would be, well, 5 and 3. So 5 and negative 3. So 5 times negative 3 is negative 15. 5 plus negative 3 is 2. So we factored it. All right, so let's write this polynomial in factored form. X plus 5, x minus 3. Okay, so we factored it. So what? Well, notice that the remainder here is 0. So if you compare this to the quotient form, there is no remainder here, right? No remainder. Because there's nothing added on the outside. So what this should tell you is if there's no remainder, that means that you can write this in factored form. That means that these two are, this is a factor of p of x. And this is also a factor of p of x. So if the remainder is 0, that means that those two are factors. They go in perfectly. So now, what happens if we plug in these two numbers that we found here, right? So now let's go ahead and see, well, what makes this equal to 0, right? So what makes x plus 5 equal to 0? So remember the 0 product property? So just a quick review of the 0 product property. So if we were to set these factors equal to 0, then that means that if I had to solve them individually, right? So x plus 5 is equal to 0, x minus 3 is equal to 0. Okay, then I solve them. So what makes this equal to 0? Well, it's going to be x equals 3 because you add 3 to both sides. And then what makes this equal to 0? Well, you subtract 5 on both sides, so you get negative 5. So those are the two numbers that make it equal to 0. So if I knew that negative 5 was a 0 to the polynomial, then that means I know that x plus 5 is a factor. So now, what happens if we plug in negative 5 into the polynomial, right? Well, you get p of negative 5. Let's plug in x into the polynomial. So plug it into there. Well, we get negative 5 plus 5 and negative 5 minus 3. Negative 5 plus 5 is 0. So this is going to be 0. This is one of the theorems, right? So one of the theorems that we're going to talk about is if you plug in negative 5 or any number into the polynomial and you get 0, this means that that number that you plugged in is related to the factor of that polynomial. So in the case of negative 5, the factor was x plus 5. In the case of 3, the factor is going to be x minus 3. And this is key. Now if you plugged in, let's try plugging in x is equal to 1. So let's try x equal to 1. So plug in x equals 1. What do we get? We get p of 1 equals, now we're going to plug in here. We got 1 plus 5 times 1 minus 3. So we have 6 times negative 2, which is negative 12. Okay, so what this is telling me is that I'm not getting 0. So since I'm not getting 0, that means that x minus 1 is not a factor to this polynomial. So this is not 0, so this means that x minus 1 is not a factor. How did I get x minus 1? Well, you use the number that you plugged in, and then you do the minus version of that, the opposite. So it's going to be x and then negative 1. If I plugged in negative 2, then my possible guy would be x plus 2. Let's do that one more time. So if I plug in x is equal to negative 2, so I get p of negative 2 equals negative 2 plus, we're plugging it into x here, right? So negative 2 here and here. So negative 2 plus 5, negative 2 plus 3, or minus 3, I'm sorry. And then we get we get positive 3 times negative 5, which is negative 15, which is not 0. That means that, if I convert that, that means that x plus 2, the opposite sign, x plus 2 is not a factor. And we can prove this, right? So if we were to do x plus 2, we're going to do one more thing here to illustrate this to you. So now we talked about that we could factor, and if we factor, we get no remainder, right? If it factors perfectly. And if we take that number and we plug it in, we get 0. And then we illustrated that if we plug in any number and you do not get 0, this means that that number is not a factor, right? That number related to the polynomial. Now we're going to show this with long division. So let's look at x plus 2 here, and we'll compare that. So let's do x plus 2 dividing into, and then the original polynomial. Let's use the original polynomial right here, x squared plus 2x minus 5. All right, so I'm practicing our division. We have x goes into x squared x times. So x times x is x squared. X times 2 is 2x. So far, so good. Subtract. That's going to be 0, 0. Bring down the minus 5. All right, well, looks like we have a remainder, right? Let me double check here. Oh, this should be a 15. I apologize. So we got minus 15. So it looks like we have a remainder. All right, well, what does that remainder look like? That remainder looks exactly what we got when we plugged in. Right here. So when we plugged in negative 2, we got the same number that we get when we divide. So this is part of a theorem, or two theorems that we'll talk about. So when you divide and get a remainder, that's the same thing as plugging in the number related to that divisor. So the number related to this divisor here, x plus 2, is negative 2. All right, so let's talk about that, those two theorems. So the remainder theorem, first one, states that if a polynomial is divided by x minus a, then the remainder is p of a. So for example, if p of x is divided by x plus 2, then the remainder of that, so then the remainder is equal to p of negative 2. So that's an example. Here's another example. If a polynomial is divided by x minus 5, then the remainder, this r stands for remainder, is equal to p of 5. So it's always the opposite sign, right? So if it's plus 2, it's minus 2. If it's minus 5, it's plus 5. So this is really neat because this means that if you plug in the number, you can get the remainder automatically. So then that helps us with the factor theorem. The factor theorem states that the expression x minus a is a factor of a polynomial if and only if you get 0 when you plug in that number into the polynomial. Just like the example that we did, right? So for our example, this was the example that we just looked at. we had x squared plus, we had 2x minus 15. So x squared plus 2x minus 15. So when we plug in p of -5, we get 0, which means our remainder is 0 when we divide p of x by x plus 5. Do the opposite sign. So that's how these two things are related. The remainder is tied into plugging in for x, which is tied into this factor stuff. So these two theorems kind of unite this idea. All right, so how do we use them? So the remainder and the factor theorems, you want to use them to determine whether the given binomial is a factor of p of x. So they give us p of x, our dividend, I guess you could say, and our binomial, x minus 6. So two ways that you can determine whether it is a factor, right? With the remainder theorem, you could divide the two things, and if you get a remainder of 0, that means it is a factor. With the factor theorem, what you could do, you could plug in x is equal to 6, positive 6, the opposite sign of this. Plug that into the polynomial, and if you get 0, that means that you have a remainder of 0, which means that it is a factor. So let's talk about those two ideas. So let's look at, the remainder theorem part. So to do this, we need to divide the two polynomials together. So we need to divide x to the 4th minus 8x cubed plus 16x squared minus 23x minus 6. We're going to divide that by x minus 6. All right, I always do this, but I need a little bit more room here. Okay, I think that's good enough. All right, so x goes into x to the 4th, x to the 3rd times, because we had 3 x's plus 1x makes 4, so now we got 4. And then x cubed times negative 6 is negative 6x cubed. All right, now we subtract. So x to the 4th minus x to the 4th is 0. Two negatives here make this a positive. So negative 8 plus 6 is negative 2x cubed. Bring down the 16x squared. All right, so x, how many times does x go into negative 2x cubed? Well, we're missing 2 x's, right? And it's negative, right? Because this is going to be a negative number here. And then we're missing a negative 2. So there you go. So we got negative 2x squared. Then you multiply negative 2x squared times x is negative 2x cubed. Negative 2x squared times negative 6, positive 12x squared. Now we subtract. You can get rid of those arrows now. So now two negatives here make this a positive. So this is 0, cancels away. 16 minus 12 is 4x squared. Bring down the minus 23x. And then we have x goes into 4x squared. Well, there's a 1 here, right? So 1 goes into 4 times, positive. And then x goes into x squared x times. So we got 4x here. Let me rewrite this, 4x. So we get 4x squared. And then 4x times negative 6 is negative 24x. So subtract those. That cancels. Two negatives make it positive. Negative 23 plus 24 is 1. So 1x. Bring down the minus 6. We're almost there. How many times does x go into x? Just one time. So 1 times x is x. 1 times negative 6 is negative 6. So we have no remainder. So no remainder here. Which means that since the remainder is 0, this means that x minus 6 is a factor of p of x. So that's the remainder theorem. So now we got the remainder theorem, we need to do our factor theorem, right? So how do we do that? Well, we just we plug in. So in this case, we have x minus 6, so we're going to plug in x equals positive 6 into the polynomial. So plug in x equals 6 into p of x. So let's do that now. So we get p of 6 equals, we have 6 to the 4th power minus 8 times 4 to the 3rd power. We're plugging this, remember, we're plugging this into x here, 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 everywhere. And there's too many arrows here, so let me erase this. There you go. Plug it into those 4 x's there. So minus 8 times 4 cubed plus 16 times 4 squared minus 23 times 4 minus 6. All right, if you plug this in, you're going to get 0. So if you were to do the math on the calculator, you get 0. All right, so since you get 0, so since p of 6 equals 0, like we said earlier, this means that since p of 6 equals 0, that means that x minus 6 is a factor of p of x. All right. Now let's look at part B. Same deal. So now we can kind of go through it a little bit faster. So x to the 5th minus 5. Oops, we are missing a 4 power, right? We have 5, 3, and 2, and 1, but we don't have 4. So let's remember to include the 4th power. So we're going to divide that by x plus 3. So now x goes into x to the 5th, x to the 4th times. So x to the 4th times x is x to the 5th. X to the 4th times 3 is 3x to the 4th. Subtract. So x to the 5th minus x to the 5th is 0. 0 minus 3 is minus 3. And then x to the 4th. Bring down the minus 5. So now we have, so we got x, or so 1x, so 1 goes into negative 3 times, and then we are missing 3 x's to make x to the 4th. So we get this times that is minus 3x to the 4th, minus 3x cubed times plus 3 is minus 9x cubed. Subtract. 2 negatives here make a positive, 2 negatives here make it positive. So we got negative 3x to the 4th plus 3x is cancels. Negative 9 plus 5, or negative 5 plus 9 is positive 4, x cubed. Bring down the 9x squared. So 1 goes into 4 4 times, positive. X goes into x cubed, x squared times. Again, multiply. So we got 4x cubed, and then 4 times 3 is 12, 12x squared. Subtract. Cancels. 9 minus 12 is negative 3. Bring down the minus x. The more you do this, the faster you'll get to it, and then it won't be so bad. So 1 goes into negative 3 times. We're missing an x though, so x times x is x squared. So we get negative 3x squared. So now we got negative 3x times 3 is negative 9x. Subtract. 2 negatives here make a positive, positive. This is 0. Negative 1 plus 9 is 8. Now we're going to bring down the 3. All right. So now we have 1 goes into 8 times. So 8 times x is 8x. And then 8 times 3 is 24. Subtract. 0. 3 minus 24 is negative 21. So that's our remainder. So now let's do the remainder. So since our remainder is not equal to 0, this means that x plus 3 is not a factor of p of x. So that's by the remainder theorem. All right, so now let's do the factor theorem. So that means, we're gonna plug in, negative 3. So our binomial is x plus 3, right? Okay, so let me write that out here. Our binomial is equal to x plus 3, which means that we're going to plug in negative 3 into the original polynomial. Okay, so you always switch the sign. So plug in negative 3 into the original polynomial. And I'll write down the original polynomial just so that we have it for reference. I'll write down the original polynomial down here. All right, so let's focus on that. So that's our original polynomial. So we're plugging negative 3 into x. So x cubed, and then 9x squared minus x plus 3. Now, if you did this, you're going to get negative 21. All right, so which is, the same number that our remainder was when we divided. So we're going to get negative 21, which means our remainder is negative 21. So since p of negative 3 does not equal to 0, this means that x plus 3 is not a factor of p of x. All right, so we have essentially our two things here, and here. All right, so go ahead and give it a try, pause the video, and we'll talk about these in just a little bit. All right, so let's go ahead and use the theorems. So we just want to see, is x minus 4 a factor of that polynomial? So we can do division. Okay, so x goes into x cubed twice, x squared times. All right, x squared times negative 4 is negative 4x squared. Subtract, cancels. Two negatives make a positive. Negative 10 plus 4 is negative 6. So I'm going a little bit faster through these, just because we've done a bunch of these. Just kind of going through the motions here. Bring down the 28x. X goes into, 1x goes into negative 6. So negative 6 times. We're missing 1x though. So that makes it negative 6x squared. Negative 6 times negative 4 is positive 24 with an x. Subtract. That goes away. 28 minus 24 is 4x. Bring down the minus 16. So 1 goes into 4 times. No more x's left over. 4 times negative 4, or 4 times x is 4x. 4 times negative 4 is negative 16. So that was these arrows here that I was doing. And then subtract them, and you get 0. All right, so that means our remainder is equal to 0. So since our remainder is 0, this means that x minus 4 is a factor of p of x. All right, so that's method 1. That's the remainder theorem. Now let's do the factor theorem. So the factor theorem is we're going to plug in, so our binomial is x minus 4 here. So that means we're going to plug in x is equal to 4. So plug it into our polynomial p of 4. So we got 4 cubed, 10x squared, 28x, and then minus 16. So you do that on the calculator, you're going to get 0. So since p of 4 is 0, x minus 4 is a factor of p of x. All right, so let's look at part B. All right, so let's go ahead and do part B. So we're going to do x plus 5 divided into 2x to the 4th plus 9x cubed minus 2x squared plus 6x minus 40. Could make this a little smaller. All right, so x goes into 2x to the 4th twice with 3 x's left over, or yeah, 3 x's to make 4. We're going to subtract. 2 times 5 is 10, so it'd be 10x cubed. So we subtract, so that goes to 0. 9 minus 10 is negative 1. Bring down this guy. So 1 goes into negative 1 times, and x goes into x cubed, x squared times. Negative x squared times positive 5 is negative 5x squared. So we got 2 negatives here, so that's positive. 2 negatives here, positive, so that goes away. Negative 2 plus 5 is 3x squared. Bring down the 6x. All right, so 1 goes into 3 times, and you have an x left over. X goes into x squared x times. So we have 3x squared. 3x times 5 is 15x. Subtract. Cancels. 6 minus 15 is negative 9. Bring down the minus 40. Okay, so 1 goes into negative 9 times. So negative 9 times x is negative 9x. Negative 9 times 5 is negative 45. Subtract those two. So positive, 2 negatives is positive, that's 0. 2 negatives here, positive. Negative 40 plus 45 is 5. So we got a remainder of 5. So since the remainder is equal to 5, this means that x plus 5 is not a factor of p of x. Okay, so there's that. That's for the remainder theorem. Now we need to do the factor theorem. So for the factor theorem, we're going to take this x plus 5 and we're going to plug in negative 5 into the polynomial. So we have p of negative 5 equals, so we're going to plug it in here, 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 and here. So we have 2 times negative 5 4th power, 9 negative 5 to the 3rd, 2 times negative 5 to the 2nd, 6 times negative 5, and negative 40. So if you did this on the calculator, I'm not going to spend time doing that on the calculator right now. So if you did it on the calculator, you're going to get equal to 5. So since p of -5 is not equal to 0, that means that x plus 5 is not a factor. All right, so there's a lot to it, as far as the division part. That part takes a while, but the concept is very simple. If it divides into it, you get a remainder of 0. If you plug in whatever you divide it into in a number format and you get 0, that means it goes into it. So these two theorems are kind of working together in tandem. All right, thank you for this lesson, guys. Thank you for listening to this lesson and viewing this lesson, and I hope you got something out of it. Next time, we're going to be talking about 3-5, zeros of polynomial functions. I'll see you in the next video.